Okay, so welcome back. So for this video, we're going to discuss about centroids. Okay, so we have here a built-up section. So we need to determine the distance h bar from the bottom. So this is the bottom of the base plate to the centroid of the built-up structural section. So the centroidal x-axis is h bar. So we need to determine our distance y. The centroidal y-axis, of course, is at the center. Okay, so it is located here by observation. Okay, so we need to determine h bar, and that h bar is the y distance. Okay, so what I'm going to do, this is identical, and this is mag-isa lang siya. So what we're going to do is pagsasamahin na natin yung identical. So we're going to combine the identical. So the first thing to do is, as I have here a angle bar, so what I'm going to do is to cut it into two parts. So you have here part 1. At this portion, I am going to cut the angle bar here. Okay, so we are to neglect the curve here, the very small curve. It is negligible. Okay, so we're going to cut it into two parts. So take note, the height here is 50, and the thickness of the leg members is 10. So 50 minus 10, that is 40. So that is 40 by 1. So the size is 10 by 40. Then for part 2, that is, take note, this is 160, this is 180. 160 minus 80 is 80. Divided by 2, that is 40. So that is 40 times 10. Okay. Next would be the part 3. So this is 120 times the thickness of 10. So 120 times 10. And lastly, we have the base plate. It is 160 times 10. Okay, so that is the size. Now, we determine the area. So for the area, it is 10 times 40. That is 400. But take note, there are two of them. So we have 1, 2. So that is times 2. So the area is 800. Next, we have here the part 2. We have 10 times 40. But then again, there are two parts. So times 2. So that is 800. Next, we have here the part 3. We have here 120 times 10. So 120 times 10. That is 1,200. But there are two of them. So times 2. So that is 2,400. Lastly, we have 160 by 10. So 160 times 10. So that is 1,600. Get the summation. So 1,600 plus 2,400 plus 800 times 2. The summation is 5,600. Okay. Next is determine the individual centroidal distance, or the centroidal distance of each member with respect to the base of the bottom of the base plate. Okay, so from h bar, we have here our reference here. We have our reference here, rather. So part 1, it is acting here. So the center, which is 40 divided by 2, you have 20. 20 plus 10 plus 10. Okay, so this is h1. So h1 here you have 20 plus 10 plus 10, that is 40. Now for part 2, that is 10. Of course, it will be acting at the center, so 10 divided by 2 is 5. So this is h2. So for h2, it is 5 plus 10. So that is 15. Next, for part 3, it would be acting at the center of the 120. So at the center of 120, it would be 60. 120 divided by 2, that is 60, plus 10. So that is 70. That is h3. And lastly, we have here h4. h4 is acting at the center of the base plate, so that is 5. That is h4, and that is equivalent to 5. Okay, determine the h times a we have here 800 times 40. We have 32,000. We have here 800 times 15. We have 12,000. And we have here 2,400 times 70. We have here 168,000. Lastly, we have 1,600 times 5. We have 8,000. Now get the summation. So plus 1,168,000 plus 12 plus 32. And that is equivalent to 220,000. Okay, so by Varignone's theorem, we can determine the h bar. So we have here the area total times h bar is equivalent to the summation of h bar times a. So what is our area total? Area total is 5,600 times h bar is equivalent to the summation of HA, that is 220,000. H bar therefore, so cross multiply, H bar therefore is equivalent to 220 divided by 5,600, and that is equivalent to 39.29 mm from the base. So this is our H bar. More or less it is located here. So this is the location of the centroidal x-axis. Okay, so before we proceed, we have here the equations or the formula to get the x bar, the y bar, so that to determine the centroids of our common geometrical figure. So we have here the triangular area, quarter circle, semicircle, quarter elliptical, semi-elliptical, parabolic, semi-parabolic, parabolic, parabolic spandrel, general spandrel, and circular section. You also have here your quarter circle arc, semicircular arc, and the area or arc of circle. So these are the formulas to determine the centroid. So we have here problem number 2. Locate the centroid of the composite figure. So for this composite figure, we have 3 parts. Okay, so we have here the quarter circle, we have here the triangle, and we have here the semicircle. Okay, so for part 1, it is the quarter circle. So what is the area of a quarter circle? The area of a quarter circle is pi r squared, but it is, since it is quarter, divided by 4 times a radius of 3. So 3 squared. So it is 7.07, okay, mm squared. Next, you have here the triangle. So for the area of the triangle, that is this is 6, this is 6 minus 3, that is 12. 6 plus 6, that is 12, minus 3, that is 9. So 9 times 3 times 0.5, since it is a triangle. So that is 13.5. And lastly, we have here the semicircle. We have pi over 2, because it is a semicircle, times 6 squared. And that is equivalent to 56.55. But mind you, part 1 and part 2 are voids. Ito lang yung hahanapan natin ng hanapin natin yung centroid. Okay? So, therefore, area 1 is negative, area 2 is also negative. Next, we need to determine our x bar and y bar of each of this figure. So, since I do not have any assigned axis, what I'm going to do, or given axis, I'm going to do is to assign. So, let's say this is my x-axis, and this is my y-axis here. Okay, so this is my y-axis. So, determine the x bar. So what is the x bar? The x bar with respect to quarter circle is given by the formula for a quarter circle. So that is 4r over 3 pi. Same with the y bar. So for the x bar of the quarter circle, we have here, so for part 1, x bar is equivalent to what is r? 4 times 3 divided by 3 pi. So 3 will cancel out. It is only 4 over pi. And that is equivalent to 1.27. Okay, so since it is a quarter circle, it is the same. So this is 1.27. This is also 1. No. 1.27. Yeah, 1.27 with respect to y-axis. So, but with respect to x-axis, it is 1.27 plus 3. Because take note, this is my y bar here. So this is that is y1 bar. Okay, so that is 1.27. So this short distance here is 1.27 plus a radius here of 3. So that is 4.27. Okay. Next would be the part 2. So for part 2, we know for x bar, it is 1/3 from the base. So what is 1/3 of 3? It is 1. Okay. Then for y bar, it is 1/3 from the base. And this is equivalent to 9. Am I correct? Yes, because 12 minus 3 is 9. And 1/3 of 9 is 3. So y bar is equivalent to y bar here is located to 3, but it is coinciding with our x-axis. Therefore, y bar is equivalent to 0. Okay. Next, we have here the semicircle. So for the semicircle, so we have here the part 3. So for the semicircle, x bar is equivalent to 4 times the radius of 6 divided by 3 pi. And that is equivalent to 4 times 6 divided by 3 pi. That is 2.55. So it is, the x bar is 2.55. But for the y bar, it is coinciding. So it is coinciding with respect to our x bar. Okay, so that is 0. So we can now solve for our x bar and x bar times a and y bar times a. So what is x bar? 1.27 times 7.07. So that is negative 8.979. So let's use, let's try to use the 4 decimal. Next, we have the y. 4.27 times 7.07. That is negative 30.1889. Then this is negative 13.5. This is 0. This is 56.55 times 2.55. That is equivalent to 144.2025. And this is equivalent to 0. So get the summation of the x bar times a. We have 144.2025 minus 13.5. So the summation is 1 to 1.7236. Then for y times the area, we have negative 30. Wait. Yeah. Tama. So negative 30.1889. Okay, so by Varinian's theorem, the summation of the area times h bar is equivalent to summation of area times h bar, or let's say no, it's not h bar this time. It is the summation of area times x is equivalent to the summation of x bar times the area. Okay, so x is equivalent to, what is the summation of xa? We have 1 to 1.7236 divided by the summation of area, and the summation of area is 56.55 minus 13.5 minus 7.07. That is equivalent to 35.98. So this is 35.98. X therefore, or centroid x, is equivalent to, we have 121.7236 divided by 35.98, and that is equivalent to 3.38, and that is in mm. Now for y is equivalent to the summation of y bar times the area over the summation of area, and that is the equivalent to negative 30.1889 divided by the summation divided by 35.98, and that is equivalent to negative 30.1889 divided by 35.98, and y is equivalent to negative 0.84 mm. Okay, how should we interpret this one? So this is my x reference here. So the centroid is 3.38 positive. So if this is 3, more or less, x bar is located here. Then y, this is my my reference for y, and it is negative, therefore it is going down by 0.84. Therefore the centroid is located here. So that is my centroid.